In this video, we have to solve the exercise of the first series of exercise in geometric crystallography. First question, give the coordinates of the nodes N1, N2, N3, N4, N5, and N6. To give the coordinates of a node, we have to do the translation from origin O to this node. For example, to do or to determine the coordinates of N1, we have to do the translation from O to N1, which is 1A minus 1B. And we say that the coordinates of N1 are 1 and minus 1. In the same way, for N2, we have to do translation 1A plus 1B. The coordinates are 1, 1. 1A plus 1B. For N3, we have to do the translation 0A plus minus 1B. The coordinates of N3 are 0, minus 1. For N4, we have to do minus 3A plus 2B. Minus 3A plus 2B. That is this translation here. And we obtain that the coordinates of N4 are minus 3 plus 2. For N5, we have to do 1A plus 0B, and the coordinates of N5 are 1, 0. Finally, for N6, we have to do the translation minus 2B plus 1B, and the coordinates are minus 2, 1. We pass to the second question. Determine the indices U1, V1, U2, V2, U3, V3 of respective rows R1, R2, and R3. We begin with this row R1. We have the first node N1 here and the second node N5 here. Remark that this node N1 and N5 are consecutive. So this node has coordinates, these coordinates here. And to find U1 and V1, we have to do the difference between the coordinates of N5 and the coordinates of N1. U1 equals U5 minus U1 equals 0, and V1 equals V5 minus V1 equals 1. And the row R1 will be denoted 0, 1 within brackets. In the same way, we can find U1 and V1 with taking N5 as first node and N2 as second node. Here also we have the two nodes are consecutive, and we make the same work, and we find that U1 equals 0 and V1 equals 1 as earlier, and the row is denoted by the same notation. Now, if we take as first node N1 and second node N2, N1 and N2, here we remark that there is another node between these two nodes. And here we find as U1 equals 0 and V1 equals 2. And the row will be denoted by 0, 2 within brackets. But we know that U and V must be coprime. Here we divide this indices 0, 2 by the common divisor 2, and we obtain the first notation as earlier 0, 1. 0 divided by 2 gives 0, and 2 divided by 2 gives 1. Now, if the translation is, or if Now, if the row is traversed in the opposite direction from N2 to N1, in this direction, the first node is N2 and the second node is N1. We note the row by 0, -1 or 0, 1 bar within brackets. Here we have to, if we change the sense or the sense or the direction of traversing the row, we have to change the sign of these indices. -0 equals 0, we note 0 here, and -1, we note -1 here, or 1 bar within brackets. If we want to determine the indices U2, V2 for the row R2, we make the same work, and we find for R2 by taking first node O and second node N4, we find that U2 equals -3 and V2 equals 2. And the row R2 is denoted by -3, 2 within brackets. For the row R3, we take the first node N5 and the second node N6. And we calculate U3 is equal to -3 and V3 is equal to 1. The row 3 will therefore be denoted -3, 1 or 3 bar 1 within brackets. Now we are going to give the expressions of the periods or parameters P1, P2, P3 of the respective rows R1, R2, R3, depending on the linear parameters A and B and the angular parameter gamma. We know that the period of a row is equal to the distance separating two consecutive nodes of the row. Two consecutive. Remark that this word consecutive. Here for row R1, the two nodes consecutive are N1 and N5. For example, we take the vector N1, N5 and we make the scalar product of this vector, and we find that this product is equal to B22, and hence P1 equals square root of B22 equals B. For R2, we find in the same way that the distance between O and N4 is equal to this expression, and by taking the square root we obtain P2. In the same way, P3 is equal to this expression. Now we pass to the application, digital application, by taking A equals 5 angstrom, B equals 4 angstrom, and gamma equals 30 degrees. Here we find that P1 equals 4 angstrom, P2 equals, this expression equals 9.01 angstrom, and P3 equals, this expression equals 11.71 angstrom.